Lore. TP2, biomass and tropic levels. Learning target. I can identify the proportion of organisms at each tropic level by correctly identifying producers at the lowest level and consumers at the highest levels. Ultimately, the skill is what we're looking for. Can you use your knowledge of food chains/webs, energy and matter flow to create a visual model to explain how they work? First, read the article All Life on Earth in One Staggering Chart, which I've got pulled up here. Here we go. All life on Earth in one staggering chart. Scientists estimate the mass of all life. It's mind-boggling. By weight, human beings are insignificant. If everyone on the planet were to step on one side of a giant balance scale and all the bacteria on Earth were to be placed on the other side, we'd shoot violently upward. That's because all bacteria on Earth combined are about 1,166 times more massive than all of the humans. Comparisons to other categories of life similarly demonstrate how very, very small we are. As a sweeping recent study of the proceedings of the National Academy of Science finds, in a consensus sorting all of the life on Earth by weight, measured in gigatons of carbon, the signature element of life on Earth, we make up less than 1% of life. There are an estimated 550 gigatons of carbon of life in the world. A gigaton is equal to a billion metric tons. A metric ton is 100 kilograms, or about 2,200 pounds. We are talking huge, mind-boggling terms here. So using the data from PNAS, we tried to visualize the weight of all life on Earth to get a sense of scale of it all. All life on Earth in one chart. What you'll see below is some kind of tower of life. Each large block of this tower represents a gigaton of life. The blocks are grouped into broad kingdoms. They are protists, like microscopic lives of Amambe, archaea, single-celled organisms somewhat similar to bacteria, fungi, mushrooms and other types of fungus, bacteria, you're familiar with these, right? Plants and animals. As you can see, plants dominate our world. If the Tower of Life were an office building, plants would be the main tenants taking up dozens of floors. Main tenants taking up dozens of floors. Comparatively, all of the animals in the world, seen in the gray in the tower, are like a single retail shop. A trendy one, to be sure, on the ground floor. Here's our nice chart. 4 gigatons, 7 gigatons, 12 for fungi, bacteria 70, plants 450 gigatons of carbon. As you can see, it takes up a lot. And then we have all animals is 2 gigatons, and humans are 0.06 gigatons. And if we zoom in on all animal life, we again see how insignificant humans are compared to everyone else in the kingdom. Insects outweigh us by a factor of 17. Even thin clams weigh more. So we have humans, insects, fish, livestock, wild mammals, wild birds. Each smaller cube equals 1,000 tons, roughly the weight of 2,000 cows. So one of those cubes equals 2,000 cows. What's missing from this chart is just as important. Yet despite our small biomass among animals, we have had an overwhelmingly huge impact on the planet. The chart above represents a massive amount of life, but it does not show what's gone missing since human population took off. The authors of PNAS article estimate that the mass of wild land mammals is 7 times lower than it was before humans arrived. Keep in mind, it's difficult to estimate the exact history of the number of animals on Earth. Similarly, marine animals, including whales, are are a fifth of the weight they used to be because we've hunted so many near extinction. So many to near extinction. And though plants are still the dominant form of life on Earth, the scientists suspect there used to be approximately twice as many of them before humanity started clearing forests to make way for agriculture in our civilization. The census in the PNAS paper isn't perfect, though remote sensing, satellites, and huge efforts to study the distribution of life in the ocean make it easier than ever to come up with estimates. The authors admit there's still a lot of uncertainty, but we do need a baseline understanding of the distribution of life on Earth. Millions of acres of forest are still lost every year. Animals are going extinct 1,000 to 10,000 faster than you expect if no humans lived on Earth. 60% of primate species, our closest relatives on the tree of life, are threatened with extinction. We have to know how much more we stand to lose. There's our article. So if we go back, it says, consider the size of the biotic components in a world ecosystem. Compare their differences as you start to think through the next step below. Consider the following food web/chain. Notice what ecosystem it is, and the animals/plants and the abiotic factors are present. So we have sunlight, one-celled life, shrimp-like creatures, small fish, mackerel, tuna, large shark. Numbers of individuals in the ecosystem. We have 9,000 large fish, 90 million phytoplankton, 900,000 small fish, 900 large shark, 90,000 medium/large fish, and 9 million zooplankton. Using the food web and data table above, arrange the organisms as their relative data into a model that represents accurate trophic levels based on biomass. Include written responses to the following analysis questions. 1. Explain what your model shows about the ecosystems and its component biofactors. 2. Why did you choose the particular shape or structure? Cite specific evidence from the above article. And 3. In what ways was your thinking about biotic factors changed?